Cool, let's do it. Okay, so yesterday, everybody, we talked about an introduction to the excretory system, got a little bit of familiarity with the overall urinary system, right? So we talked about the kidneys and the ureters and the urinary bladder and urethra. We then zoomed in to the kidney itself to talk about the cortex and the medulla and nephrons and the renal pelvis. And then we did a little bit further zooming into a nephron. You guys remember that from yesterday, right? Okay, so today, the focus is going to be on the following objectives. So if we go to our unit objectives, we go full screen. We should be familiar with the first objective. We should be able to define excretion. Somebody define it for me, please. Silence. The elimination of metabolic waste from the body. That is correct. All right, good. And we know that it's different from the process of elimination. Already passed? Okay. Thank you. We should be familiar with 10.2.2, drawing and labeling a diagram of the kidney. Yes, we worked on that yesterday. Any questions about that? No, and if you click through the Prezi, you're going to see the urinary system, right? And you're going to see the kidney and nephron. But for now, we should just have some familiarity with that. Let's look at annotating the diagram. We're going to go into more detail about that today. So 10.2.3, we're going to get more detail today. 4, we're going to get more detail. 5, we should know. What is osmoregulation? Yes, regulating the balance of water in our bodies. Okay, good. And then 6, 7, and 8 we're focused today. I probably will not get to 9 until we do a follow-up to this lecture on Friday. Any questions about what we're covering and where we are with the objectives? Nope? All right, so there's a group that put together this awesome kidney animation. So I'm going to go down to our unit Anatomy and Physiology 2. And I labeled it Awesome Kidney Animation. Now, in the past, I used to be like, oh, I just tell my students, go through this and click through it and so forth. What I found is that students either don't go through it thoroughly enough because they're in a rush and have other priorities, which is that's no fault of them, I understand that. Or there's confusion about what's actually going on and how to use this. So I'm going to actually go through with you in class. So the introduction of this, this is from biologymad.com, which is a really cool resource for us. So the outside is the cortex of the kidney. That's the dark brown. Then the light kind of tan color is the medulla. And then this white section here is the renal pelvis. Right? So we've got the urine actually draining to the renal pelvis and then out the ureter to the urinary bladder. You guys are with me in that? Yeah, so we're oriented to it. What about these vessels? What's the blue vessel represent?
Vein.
The vein, right? Carrying the filtered blood back to the heart. And what about the red?
Renal artery.
The renal artery, good. All right, so that's just the quick little introduction. If we zoom in, you're going to see the image of a nephron come up. And most of our class period today is going to be a discussion of the nephron and how it works. So, okay. So as from yesterday, we drew this out on the backboard to try and get our heads around the anatomy. So we've got the afferent arteriole bringing blood into the glomerulus. The glomerulus is a network of capillaries. We have the efferent arteriole bringing blood away. Something that's done really well here is if you look at the diameter of the afferent and the efferent arteriole, do you see a difference in the diameter?
Yeah.
Yes. That's actually that's accurate for sure. The afferent arteriole has a wider diameter, so that when you get to the glomerulus, you end up with a lot of pressure, a high blood pressure in the glomerulus. And the efferent arteriole is actually going to help maintain function of the kidneys when your blood pressure changes. And we'll go into more detail about that most likely on Friday. But for now, just be aware that they are a different diameter and that you end up with high blood pressure in the glomerulus, forcing all the substances out of the bloodstream and into the filtrate. Okay? So following the blood system, the afferent arteriole, the glomerulus, the efferent arteriole, which connects to the vasa recta, which would come here along the loop of Henle. Vasa recta isn't really diagrammed here, so I'm going to go to the board and just kind of give you an idea. And you're going to need to keep this in your head. If you were to look at the vasa recta, it's a network of capillaries that come along the loop of Henle. All right, so whenever something leaves the filtrate,